Dendrites can cause the failure of printed circuit board assemblies. Dendrites can form on the printed circuit board, on the component, underneath solder mask, or also underneath conformal coating. My name is Bob Willis and welcome to Defect of the Month. Every month I create a video showing one particular type of defect, hopefully explain how it's occurred and possibly how to overcome it. Hopefully you'll find these defects useful, and please pass them on and subscribe to this particular channel. Now, dendrites can form on a printed circuit board. Let me just illustrate this with an animation. Here we've got two tracks and we put a droplet of deionized water on the surface between the two tracks. We're passing a voltage between the two contacts, and what you're looking at is a little Christmas tree, as I tend to refer to it, growing between those two surfaces. This is effectively dendrite formation. The very first time I ever experienced dendrite failures was on a product which was in operation only for a few days, but in a very hostile environment. This image shows how corrosion has occurred underneath the solder mask. Now, this really was poor design. The solder mask has been defined right up to the pin, and this pin was soldered using wave soldering in the process using a water-soluble flux. And what has happened is during the soldering operation, the flux has penetrated up, as it would in a normal process, but actually it remained trapped between the solder mask and the pin, and of course when a voltage was applied, dendrites and corrosion products will have formed. Now I've removed that mask from the surface of the board, you can see the debris left behind. Now I had to demonstrate how this occurred, why it could have occurred, and how we could overcome it. So basically what I did is took a number of printed circuit boards. Some I soldered with water-soluble flux, some soldered with traditional low activity flux, and some samples that I didn't use flux at all. And after that testing in high temperature and high humidity with a voltage applied to the test circuits, we could see the difference between those three examples. So it proved what actually occurred. Now, dendrites can occur underneath components, they can occur underneath conformal coating. In this example, I show you how corrosion products have actually been visible or found to be visible on a single-sided board. This was caused by poor cleaning. What happened is somebody has cleaned the printed circuit board on the opposite side. That residue has gone through the holes to the opposite side, and then during operation of this product, you can see a dendrite is very, very obviously available. Now, if you're going to attempt to look and try and find any dendrites which may be leading to intermittent failure of a product, you've got to define roughly where it is. You really want to define using test engineering to say it's around that component, it's underneath that termination, it's on that position. When you've done that, that allows you to use traditional optical inspection without damaging any of the information present, and to record the presence of a dendrite. It's also possible to do it with X-ray, depending on the size and density of the corrosion products that are left behind. In this example, I can show a dendrite forming, or has formed, under a QFN package, just back from the area where the soldering operation has taken place. A final technique I've used in the past is to use microsectioning. Now, this does sound a bit strange because you're not going to section through what effectively is thinner than a hair. So what I'm doing is actually sectioning through the board, up through the thickness of the board, so I'm coming up underneath where the component terminations are, and I can see through the epoxy resin the formation, as you can see in this optical photograph. Now, if you want to test out materials to see that they will meet your requirements, then there are IPC standards for assessment of SIR, Surface Insulation Resistance. There we can use temperature and humidity are traditional tests, and they've been around for many, many years, and very, very effective they are. However, we can take it on to the next level with a far more demanding test that was developed by NPL in Teddington in the UK. And this is condensation testing. And what we're taking is printed circuit board assemblies, test boards like these examples I've built many, many times for customers. These have all got test circuits directly underneath the components, which allows us to assess residues that might be left behind because you're running a no-clean process, or if you are cleaning, it demonstrates whether you've been successful in removing all the material from underneath the packages by measuring the SIR, or the change in SIR between a clean and a no clean, and perhaps a raw board, a basic board that it's not been subjected to any other operations. So condensation testing, what it does is condense moisture onto the surface. This photograph, which is actually a video, shows how the condensation is slowly increasing on the surface. And based on the work that NPL have done, they can define how much condensation is taking place on the surface. So that then allows them to estimate the difference in reliability of a product which possibly has gone through a process with a particular type of flux, or it's using some other metallization on the board, and or some other temperature on the printed circuit board. It also allows you to look at the sensitivity of smaller and smaller surfaces. My name's Bob Willis. This is Defect of the Month. Hopefully you'll be able to listen to another Defect of the Month in the not too distant future. Well, actually that would be 4 weeks, wouldn't it, if it's next month. Thank you very much.